let's switch gears and talk about viruses in the immune system. So your immune system is divided into two components, an innate immune system and an adaptive immune system. The adaptive immune system is what we've all learned about in terms of vaccines and antibodies and all the things, the discussion that we've had the last 4 or 5 years. You see something very specific, your immune system does, and it makes an antibody directly against that. If it's slightly different, the antibody response is not going to be as effective. So it's very highly tuned, very specific. That's the adaptive immune system. The innate immune system, on the other hand, is the one that goes out first, gobbles things up, and presents it to the adaptive immune system. But there's also something else in the innate immune system that's very important, and that is the system that has to do with recognizing damaged molecules and recognizing pathological molecules. There are certain pathological patterns, PAMPs, pathological associated molecular patterns, that the innate immune system recognizes without ever having seen it. And it can take those things out. And the greatest tool that the innate immune system has to take those things out is something called interferon. Interferon is an extremely important molecule. It has a very wide-ranging ability to take out viruses. Something that's important to understand is that with all of the variants that we've been talking about with COVID, with all of the different strains that we have of influenza, none of that matters with interferon. Interferon has very wide, and that's why it's such an important molecule. It's been said that the immune system is so well designed that there are no viruses that can infect it unless they have countermeasures. And that is absolutely true. This was first seen when SARS-CoV-2 came out. They looked at SARS-CoV-1, the original one that came out in 2002. And sure enough, that virus, SARS-CoV-1, or if you want to call it that, or just SARS, had a mechanism contained within it to neutralize and to suppress the secretion of interferon. They did some searching and they looked at SARS-CoV-2, and sure enough, MAC1, which is a gene in SARS-CoV-2, is a gene that is specifically, I don't want to say designed, but it's there to get around interferon. That should tell you how important interferon is.